Good morning, students. Let's begin our bright morning with learning science. Today, we will be continuing our lesson number 14 Measurement and Effects of Heat, part 3. So, students, in the last session, our conclusion was the temperature measuring device, that was thermometer. Thermometer is a device which can measure the temperature of the object. Thermometer can say the object's temperature is 0 degree, 5 degree, 50 degree or 500 degree and many more. So thermometer is a device which is used in small clinics to large industries. So thermometer is one of the measuring unit. Our topic name itself is measurement. So how we are measuring the temperature? It's by thermometer. And what will be the unit? The units will be degree Celsius, degree Fahrenheit and Kelvin. Now, what is degree Celsius, Fahrenheit and Kelvin? So students, I'll give you an example. You all have been visited to the doctor. Yes? You might have also heard doctor saying that you have 102 degree fever. Now, have you ever think about it? What is 102 degree? Is it Celsius or Fahrenheit? So students, always remember it is Fahrenheit. So students, do you know how much our body temperature is? A healthy person's body temperature is 37 degree. But now again the question arises, is it degree Celsius or Fahrenheit? Students, always remember it is 37 degrees Celsius. Okay students? Before going in detail with the thermometer, let's go through a short topic which we will discuss now, that is heat and temperature. We know students, we can measure heat and temperature by using a device thermometer. See students, temperature totally depends on gas. Take any gaseous medium. Whenever it is on high temperature, the molecules moves very fastly because here the molecules are unstable on high temperature. Let's suppose you have oxygen gas and wherever that oxygen gas is present, there the temperature is very hot. So what will happen? The molecules of oxygen will travel very fastly. It will try to escape. It means what happens? Because of high temperature, the molecules expands. Same how when we talk about low temperature, the molecules get contract. So students, if we have one room and the room is filled with gaseous molecule, if the room's temperature is high, the molecules will move fastly and they will try to escape from the room. And now, if in the same room and same molecules are present but the temperature is low, that is the temperature is cold. So what happens here? The molecules will come closer to each other. It means what happens? It contracts. So students, you have to keep two things in the mind. In high temperature, gas expands and in low temperature, it contracts. And now, students, velocity also depends on the same condition. What do you mean by velocity? Velocity means speed. So, what I said, on higher temperature, gaseous molecules expand. Expand means it starts running. So, velocity means speed of the gas increases. It says that here the temperature is very high. So let's run from here, which gets expand. So what happens student? On high temperature, velocity increases and on low temperature, velocity is low because it will say that the temperature is cool. So I can stay here. So it gets contracted. So on higher temperature, high velocity and on lower temperature, low velocity. Okay students? Hope so the concept of gaseous expand and contracts is clear to all. Now we will go to the topic thermometer, which we know that in thermometer we can measure the temperature by three units. First one degree Celsius, second one in degree Fahrenheit and third one is Kelvin. So students, in degree Celsius the unit is used more in industries, factories and for measuring body temperature. Second unit The degree Fahrenheit is used in clinical laboratory and hospitals. The third unit of measuring temperature, Kelvin, is used in big industries, factories, or in labs. Now let's know the relation between all three units. First, we will know the relation between degree Fahrenheit and degree Celsius. One formula arises from this relation of these two units, that is degree Fahrenheit and degree Celsius. The formula comes here is F minus 32 divided by 9 is equals to C divided by 5. Here F is degree Fahrenheit and C is degree Celsius. So students, second relation is between the unit Kelvin and degree Celsius and is given by the formula K is equals to C plus 273.15. So by this formula, here K is Kelvin and C is degree Celsius. If K is given, we can remove the unit of degree Celsius, and if Celsius is given, we can remove the value of Kelvin. So students, to get it very much clear, let's solve the numerical. Question 1. How much will the temperature of 68 degree Fahrenheit be in Celsius and Kelvin? So students, your given content is temperature in Fahrenheit, that is F is equals to 68 degree, and to find it is temperature in Celsius, and we have to also find temperature in Kelvin. So according to the formula, F minus 32 divided by 9 is equals to C divided by 5. So students, by substituting the value of F, we know the value of F is given as 68. So it becomes as 68 minus 32 divided by 9 is equals to C divided by 5. So students, we will do the calculations now. 68 minus 32 gives you the answer as 36. So now the next equation comes as 36 divided by 9 is equals to C divided by 5. Now we will do the cancellation. 9 ones are 9 and 9 fours are 36. So students, 4 divided by 1 is equals to C divided by 5. Now students, in this steps doing cross multiplication, we will get as 4 multiplied by 5. So the answer comes as 20. So we got the answer as 20 degrees Celsius. Now students, we got the answer in Celsius. According to Kelvin, formula is K is equals to C plus 273.15. So students, so we now know the value of C. So 20 plus 273.15 gives you the answer as 293.15. So students, now we got both the answer. The temperature in Celsius is 20 degrees Celsius and in Kelvin is 293.15 Kelvin. So students, this was about the numerical, which was very easy to solve by using the formula. Hope so students, you all have must been understood how to use the formula to solve the numerical. So students, now let's move to the topic thermometer. Now everyone knows a thermometer is a device used to measure temperature. So students, thermometer are of different categories. First, clinical thermometer, second, laboratory thermometer, and third one is digital thermometer. Let's know one by one about each thermometer. Students, now let's understand what is clinical thermometer. We know that clinical thermometers are used in hospital. Now students, let's learn about its structure. It has a narrow glass tube and at one end it has a bulb. The bulb is filled with the liquid known as mercury. Mercury is an element student. But students, mercury was used initially in past times. Now in advanced thermometer, in place of mercury, alcohol is used. Now how the thermometer works? The bulb side of the thermometer is kept in contact with the temperature object to be checked, and it is leave for 1 to 2 minutes. So whatever temperature of the object is absorbed by the mercury or alcohol, it gets rises up to the markings of the thermometer. You know, students, alcohol or mercury has the special property whenever it gets heat, it starts expanding. So whatever the temperature of the object is, it starts rising up to the markings which are on the thermometer. So students, as the clinical thermometer are used in hospitals to measure the body temperature, so the thermometer is designed in such a manner to measure temperature between 35 degrees Celsius and 40 degrees Celsius, because body temperature of a healthy person is 37 degrees Celsius. So this was how the clinical thermometer is designed and it works. Moving to the next one is laboratory thermometer. Laboratory thermometer are same like the clinical thermometer, except the range of laboratory thermometer is more. That is, it can measure in large spanning from 40 degrees Celsius to 110 degrees Celsius or even larger. So students, have you think over it why the laboratory thermometer has a large spanning? Students, the range of measuring is more because the laboratory thermometer are used in various laboratories to check the temperature of the chemical reaction or something else. Now students, we came to know about clinical thermometer and laboratory thermometer. Nowadays students, a new type of thermometer is there known as digital thermometer. A digital thermometer has a sensor at one end which measures the heat coming out from the body, and the measured temperature is shown in the digital box digitally. What do you mean by digitally, students? Digitally means 1, 2, 3 in numbers. So, for example, it shows as 97 degree Fahrenheit. Digital thermometers are used in home because it is easy to handle and also it can be worked easily. So students, this was all about the thermometers. So we studied about three major types of thermometers. First one, clinical thermometer, second, laboratory thermometer, and third one was digital thermometer. So students, now we will be moving further to a new concept, that is heat balancing property. Students, we know that the temperature gets absorbed in the sensor, and if the object is hot, it will show as high temperature, and if the object is cold, it will sense it and show as low temperature. Normally, what happens, students? Hot object loses heat and cold object gains heat. So students, have you ever noticed an hot object slowly gets cold because heat loss takes place. So it starts becoming cold. Cold means it comes on room temperature, and cold object comes on normal temperature because it starts absorbing or gaining the heat from the surrounding. So students, this balancing is very important, which we tell as heat balancing property. Students, this was all about the property, that is heat balancing, which is very much important. Now we will move to the next concept, specific heat. It is very interesting, student. So students, what is specific heat? The amount of heat energy required to raise the temperature of an object is said as specific heat. Students, consider any of the object and we have to heat it or we have to cool it. So, how much amount of heat is required to heat the object or to increase the temperature, or how much amount of heat is required to decrease the temperature to make it cool is known as specific heat. So students, the specific heat of an object is the amount of heat required to increase the temperature of unit mass of the substance through 1 degree. Okay students? Keep in mind students, any object is there. I have to increase the temperature by 1 degree Celsius. So how much amount of heat is required to increase 1 degree temperature? So that amount of heat is the specific heat for it. Okay students, is it clear now? Symbol of specific heat is denoted by the letter C. And the SI unit of specific heat is joule per kg degree Celsius. And CGS unit of specific heat is calorie gram degree Celsius. Formula for specific heat is Q is equals to M multiplied by C multiplied by delta T. Students, here the triangle is known as delta. It is said as or it is pronounced as delta. Now, let's understand the formula students. Let's suppose Q is amount of heat required to increase the temperature. Here M is for mass and C is for specific heat. And students, delta T is split in the two things, that is final temperature minus the initial temperature, which is given as TF minus TI. So students, have you understood? Students, I will be repeating the formula. Q is equals to M multiplied by C multiplied by delta T. Here Q is the amount of heat required to increase the temperature. M is given for mass and C is for specific heat, and delta T is split in the two, final temperature minus initial temperature. So students, this was all about the formula of specific heat. So students, this all concepts was about today's session. Students, please re-see the video to get your concepts more clear. Thank you so much students for your attention. Have a nice day.